I'm starting class.
Yes, sir, recording is started.
Okay, great. So I'm sharing my screen. Just a moment. Okay. Can you see my screen?
Yes, sir.
Okay. So in this class, we will be looking at a specific topic which is very important in our syllabus. So so in this class we will learn some methods by which uh, we can solve a block diagram problem. Okay, so normally in a specific system, some pattern of block diagram can be given to you, and the task will be to reduce the whole block diagram to a single block. Okay, so as you can see that this block diagram has several blocks in it, right? But your task is to reduce the whole the total the all of the blocks to a single block which can represent the same thing, right? Let's say uh, the task is to convert this whole diagram to a single block, so that you will give your input in this side. This is the input and this is the output, and you will pass the input in this side, and you will have the output in this side. And this block will work such a way that if you give one as an input and if you get four as the output from this diagram, then if this single block like uh, using one as your input value. Okay, so the working principle will be the same, but now in this case uh, you are just converting the whole things into a single diagram. Okay, so this diagram will be called uh, uh, as an equivalent diagram, equivalent block. Okay, so now we will be looking at how can we solve this whole diagram to a single diagram, or how can we solve the block diagram. Okay, so before going into the rules of the solving, let's first look at how a specific operator, which is very important in our block diagram. So this operator is called summing point, and this summing point is shaped like a circle. Okay, and this circle will be divided into four parts. As you can see that this is a circle, and you are drawing a X here, right? You are drawing a X like shape, and this X like shape X like shape is dividing the whole circle into four parts, right? This is part one, this is part two, this is part three, this is part four, and all of those four parts will be activated according to your use. Okay, so let's say you are using two input um, for this in the summing point, and the inputs will be characterized by the inward array. By the inward arrow. So as you can see that this signal is getting inputted, and how can we say that this is an input? Because arrow is inward here, okay? And this is also an input because this array is also inward. But this arrow is outward. That means this is representing the output of this summing point, okay? So now we can easily identify which is the output and which are the inputs, but we have to know that what is the output. If we are giving some input to it, we need to know the output. So how can we know the output? The method is very simple. always you will see some sign along with the input. So here you can see that this is an input and it has a sign with it, with it, right? And this sign is positive. And also this uh, um, this input is also having a sign, and this sign is also positive. That means the output will be an equation, which will the equation will be generated by using a simple formula. And the formula is, you have to use the sign of the first input, and you need to use the sign of the second input, and you need to construct a formula by using the sign. And as you can see that x1 is having positive sign, so you need to write plus x1 of s and plus x2 of s. Okay, so we can omit the first plus because as you can see that if we don't give any sign, uh, it basically represents a positive sign. Okay, so this x1 plus x2 is basically the output. So another exception is here. As you can see that this is having negative sign, so x2 is negative, but x1 is positive. So the equation will be plus x1s minus x2s. So here we are omitting plus because this is the first term. Okay, so this is the way you can like use your summing point in the block diagram. Okay, so this is the first thing. Now let's look into the rules of the block diagram, and these rules will be used to solve your block diagram. So pay attention to the to all of the rules, okay, that I will be discussing. So the first rule is, it's a very important rule, and you will frequently encounter the rule. You need to use this rule frequently in your block diagram. Okay, so here you can see that there are two blocks here, right? This is the first block, and this is the second block. Okay, or you can you can say that this is first block, this is second block. Okay, order is not important. So as we can say that there are two blocks here. Okay, and there is a summing point here also, right? This is a summing point, and the importance of this summing point is, this summing point, uh, the output of the summing point, which is this. Okay, this is the output of the summing point, and this output of the summing point is going into a block. Okay, and this summing point has an input which is coming from another block of the diagram. Okay, so this is the scenario of the rule 1. So I'm repeating it again. If you see a structure like that, uh, as you are having a summing point, and the summing point is taking input from a block and giving output to another block, then you should follow this rule. Okay, always try to follow this structure. The structure is, the output of summing point should go to into a block, and the summing point will have an input which is coming from another block. Okay, so this is the common structure, and if you see this common structure, then you can convert this whole part you can convert this whole part to a single block, and this block will be written as, the there are two parts here, numerator and denominator. The upper part will be the value of the block which is having the output of the summing point. Okay, so which block is having the output of the summing point? It is clearly G, right? So this G will be in the upper side. So this is the summing point. Okay, so just a moment. I'm Okay. So for this rule, what I was saying that uh, when you are writing the formula, you have two parts, the upper part and the lower part. And when you are writing the upper part, you should always write the the value of the block which is having the output of the summing point. So the output of the summing point is going into this block. So you should write the value of this block. So that is the G. And you also need to write the bottom part. So what should be the bottom part? Bottom part has two parts. One is 1. You always write 1, and then a sign. It can be plus. Sorry, it can be plus or it can be minus. Okay. So how can we identify is it plus or minus? This is another rule. The rule is, if you see, you will always see two sign here, and if you see that these two signs are similar, if you see that the two signs are similar or the same sign, then you should give negative sign here. Okay. But if you see opposite signs here, then uh, you should input positive sign here. Okay. So let's say if you have minus minus here, that means two signs are similar. So you should input you should place negative sign here. Or maybe if you have plus plus here, this case is also having the similar sign, so you should input minus here. Okay. But if you see opposite signs here, then you should input positive sign here. Okay. So this is the basics of sign, inputting sign. And the next part is simple. You just need to multiply this value and this value, which is G and H. Okay. So this is rule number 1. Is it clear?
Yes, sir.
Okay, great. Now let's go to rule number 2. Rule number 2 is very simple. If you see some block like this, let's say the block, this is the first block and this is the second block, and if those two blocks are structured in such a way that they are in series, okay, they are in series, then you can convert these two block into a single block, and that block will be the value of will be the product of first block and the second block. Okay. So G1 and G2, this is the basics of combining two blocks which are in series. So let's say you have three blocks, G1 and then G2 and then G3. Okay. So now we can convert all of these three blocks to a single block, and that block will be having a value of G1 into G2 into G3. So you just need to multiply all of the values of the blocks. If you see that the blocks are in series. So this is rule number 2. And rule number 3 is very simple. Rule number 3 is, if you see two blocks are in parallel and those blocks are getting inputted to a summing point, and this is a summing point. If you see a symbol like that or a structure like that, then you should sum the value of you should add the value of these two blocks. So G1 and G2 is getting added here. Okay. But if you see that here the sign is negative and the sign is positive, then what should be the value what should be the value here? Can you tell me the value of this block?
So one sign is positive and one sign is negative then. One plus.
What should be the value here?
Sir,
Min
minus.
minus minus.
Yes. So what is the sign of G2?
plus.
Sir, minus G1 plus G2.
Sign of G2 is positive, right? Because it is entering with Z2 sign. So, so it should be Z2 minus G1. Okay, because the sign of G1 is negative. Okay, so this is the rule number three. Am I audible?
Sir, your sound is like not coming properly. It's cutting.
Your voice is recording, sir. Maybe internet slow.
Okay. Now you should hear me properly. Can you hear me properly now?
Yes, sir.
Okay, great. So I have covered rule number two and rule number three. Now let's
Sir, can
go.
you please tell rule number
Let's
three
jump
also?
into rule number four. So the
Rule three what?
okay. So rule number three is when you see yes, when you see a sign, a negative sign here and positive sign here, then you should create the formula. You should convert this as the equation, and the equation should be the sign of G2 will be positive. So G2 will be positive, and sign of G1 will be negative. So minus G1. This is simple. Or maybe if this sign is positive and this sign is negative, then G1 should be positive and G2 should be negative. Okay.
Yes, sir.
Okay, great. So now rule number four is very important. Here you can see that you have a block of G here, and let's say you have a connection point. You have a connecting point, which is connected from this point, and this point is connect and this is the default connection. Okay, and this is the default connection. Now what you want to do, you want to disconnect this point, but you need to shift. You are trying to shift this point to this point, but you want that the signal that is coming from this part and the signal which is coming from this part should be the same. Okay, I'm repeating it again. Normally when you are the point is connected from this part, so what should be the value of this signal? Can you tell me? The signal should be R into G. Okay, I forgot to mention a thing, which is if you have a block of G and if you have an input of X, okay, so what should be the value of output? The value of output will always be the multiplication of input and the block value. So the output should be G into X. Okay, this is the very basic formula. So here you can see that the output. So what is the output? So here, what is the value of C? The value of output or the value of C will be the multiplication of R and G. So R and G will be the output. Now, as we are taking a connection from this point, so this connecting wire will also have the same value of this, right? Because you are just connecting this, you are just taking as the signal value by using a wire. Okay, so this should be the same as RG. But now, what we are trying to do, we are trying to cross this connection or disconnect this connection. Rather, we want to take this connection from the left part of this block, but we want the same value which was giving, which this signal was giving, this wire was giving. So what this wire was giving, the wire was giving RG, right? But we want RG from here also. But normally, what is the signal is coming here? Normally the signal is R, right?
Yes,
Because
sir.
this is the R signal. But we need RG. If, as we need RG, that means we need an extra G block here. Okay, if you give extra G block here, then this value should be RG, right? So the rule 4 says that if you shift a connection, if you shift a connection from right side of a block to the left side of the block, then you must add you must integrate a similar block value to the connecting point. Okay, so as you can see that when we are uh, pulling out a connection from this point to that point, that is why we need to input a block which is the same value as the block which we have shifted. Okay, so this is the rule number 4. And rule number 5 is opposite. Rule number 5 is if we want to shift a connection from left side to right side, then we should add a block, and this block will have an inverse value of this. So what is the inverse value of this? 1 by G. Okay, so this is the rule number 5. Is it clear? Is it clear or not?
Yes, sir.
Okay, great. So now let's jump into rule number 6. So rule number 6 is if you have a summing point and you have a connecting point at the right side of the summing point, okay, but if you need to like shift this connecting point to the left side of the summing point, then what you need to do, you just need to add another summing point. Okay, you just need to add another summing point, and this summing point was having two input, right? This is R1 and this is R2, and if you shift this point to that point, then automatically this signal will have R1. Okay, but you need to add another summing point here. Okay, and you just need to give another input from the another signal that the summing point was having. Okay, and the sign will be the same. This is plus, so this should be plus, this should be plus, and this should be the output. Okay, so if you shift a, a signal from right side of the summing point to the left side of the summing point, then you should add another summing point, and this summing point will be having two input as and the same sign that the original summing point was having. Okay, so this is the rule number 6. And rule number 7 is opposite. Rule number 7 is if you have a connecting point which is at the left side of the summing point, and if you need to shift this point to the right side of the summing point, okay, right side of the summing point, then what you need to do, you also need to add another summing point. But now what you need to do, you need to give the second input to here and another input here. This input will not be used, rather the output will be used. Okay, and this signal, the second signal, will get inputted with a negative sign. Okay, so this is the rule when you are shifting a point from left side of the sign point to the right side of the sign point. Okay, so this will get easier when we solve an actual block diagram. Okay, all of this rule will get easier to you. So let's solve a problem. So how can we solve this? So firstly, as we can see that this block diagram is very complicated, and this block and this block are in series. Okay, so we can use rule number 2, but the problem is these blocks are getting separated by this connecting point, right? But if those blocks are in simply parallel, series, then we can convert this to a single block which is having G1 and G2, right? But we can't do it right now because we are having a connecting point which is within the which is between G2 and G3. Okay, so what we can do, we can shift this point to that point, right? We can easily do that. We have already learned about a rule, which that rule can shift a point from left side of the block to the right side of the block. Okay, so this rule, so what is the rule? The rule is this one, rule number 5. So rule number 5 says if we shift a point from left side of the block to the right side of the block, then we should add a inverse value block to the connecting point. Okay, so we will be doing the same thing. So let's say we are disconnecting this part and we are connecting this part. Okay, as we are shifting this point to the right side of the point, so we should add a point here, we should add a block here, and this block will have 1 by, can you tell me what should be the value? 1 by
G3.
1 by G3, yes, because we have shifted, we have skipped the G3. Okay, that is why we are inputting G3, not G2, because we shifted along G2, along G3. Okay, so this is the first task. So first task is, yeah, we have shifted this point to that point, and that is why, as you can see, that H1 and 1 by G3 is in parallel, so we can multiply this two part. Here you can see, if we multiply this two part, then this will get converted to H1 by G3, and now we can see that G2 and G3 are now is in series. So now we can multiply this part. So if we multiply this two part, then the block will be G2 into G3. Okay, so this should be a single block. Is it clear?
Yes, sir.
Okay, now you can see that we have a summing point, and the summing point is having an input from a block, and summing point is giving output to another block. Okay, so this is the rule number 1, right? Rule number 1 says if the summing point is giving output to a block and taking input from another block, then we can convert this whole part to a single block, and that single block should be what value? Can you tell me the value?
Yes, sir.
So
Output
what should be the value?
output upon 1 by 1 plus
H2 by.
Not H2 by,
Sir, we have
because
G2 and
you
G3
need,
parallel block.
yes,
G2 G3 by
yes,
1 plus
yes,
G2.
it should be G2 by G3 divided by 1, and as the sign are opposite, plus and minus, that means this should be plus, and G2, G3, and lastly H2. This should be the value of the whole part. Okay, why we are inputting G2 and G3 here? Because always you need to place the value of the block which is having the output from the summing point. So here this block is having output from the summing point, that is why we are inputting G2 and G3 here. Okay, so here if we convert this whole part, yes, so if you convert this whole part, then this part should be G2 G3 divided by 1 plus G2 G3 and H2. Okay, so can you tell me which should be the next part, next step?
Sir, rule 2
Series.
series.
Yeah, yes, this is the rule 2 and this is the series part, and we can convert this two part to a single part. And what will be the value? Just you should add G1 here. And but because if we multiply this two part, you just can cancel this part and G1 will be here. Okay. So as we are having G2, G3, G1 by 1 plus G2, G3, H3 here as a single block, and you have another block here. Now, what rule should be applied here? What rule?
Rule one maybe.
Rule 1.
Yes, it should be rule one, because as you can see that G2 an input is the output of the summing point is getting input is getting passed to this block. Okay, so this is the first block, and another block is giving input to the summing point. So this is simply clearly the rule number one. So what should be the rule number one? If we apply this, obviously this should be a messy type of formula, but you need to write it. So let's write it. So what should be the upper part?
The whole thing is G2 G3 part
Yes. So G2,
Whole part.
G3, G1 divided by 1 plus G2, G3, H2 divided by 1.
plus
What should be the sign?
Plus.
Yes, the sign should be plus divide into the whole part. This part
whole
is
part into
list.
the another part.
Yes, yes. G2, G3, G1 divided by G2, G sorry 1
1
plus
plus. Yeah.
G2, G3, H2 into H1 by
G2.
G3. Sorry, G3.
Yes.
Okay. So this is the whole part. So the whole things will get substituted by this formula. So you just need to write this. You don't need to simplify this thing. You can write the same this part in your answer sheet. Okay. So if you simplify this, you will find these things, but you don't need to simplify this. Okay. You can
Sir, in
keep
question,
this part
in question,
like this.
in the place of G1, G2, there will be some numerical value, right?
Uh, there can be some numerical values, but it is not it is not always you will not always find some numerical value. You can find some symbol like
Okay.
this type of this type of question can be in your exam, or numerical value can also be in your exam. So either type of question can be in your exam.
Okay, sir.
Okay. Okay. So that was the block diagram solving part. I will provide some sample